हाँ जी बच्चों, today we will be doing amplitude modulation. In amplitude modulation, the amplitude of the carrier is varied in accordance with the information signal. Information signal के हिसाब से carrier का amplitude change करेंगे. Here we explain amplitude modulation process using a sinusoidal signal as well as a modulating signal. Okay. So what we do is, let us say that the carrier is a signal CT. Carrier C is dependent on time t, which is equal to AC sine omega CT, where AC is the amplitude of carrier and omega C is its frequency. Let it represent the carrier wave and let the message signal be MT is equal to AM sine omega MT, where omega m is the frequency of message signal and AM is the amplitude. Okay, what we have to take care is the amplitude of message signal shall be less than the amplitude of the carrier wave, and frequency of the message signal will be very much less than the frequency of the carrier wave. That is why we needed modulation. Now the modulated signal is written as CMT. The modulated signal will be written as AC amplitude of carrier plus AM sine omega MT. This is not maths, this is physics. AC, the amplitude of carrier, is added to the whole message signal sine omega CT, which is again written as, we have AC common here, AC 1 plus AM upon AC sine omega MT sine omega CT. The modulated signal now contains the message signal. So we say let AM upon AC be written as mu. This is called as the modulation index. Modulation index, which is always kept less than 1 to avoid distortion. Okay. Now over here what we say is, this can be written as AC into 1 into sine omega CT is AC sine omega CT plus AM upon AC becomes mu into AC sine omega CT sine omega MT. Okay. Now what we have in maths is sine A into sine B is written as half of cos of A minus B minus cos of A plus B. So this sine A sine B is written as mu AC by 2 cos omega C minus omega MT minus mu AC by 2 cos omega C plus omega M into T, where omega C is the carrier wave frequency. Omega C is the carrier wave frequency. Carrier wave frequency. Omega C plus omega M is called as upper side frequency or upper side band. Omega C minus omega M is lower side frequency or lower side band. Okay. Now the modulated signal, this is the modulated signal CMT. This whole modulated signal is passed. The modulated signal now consists of the carrier wave, this is the carrier wave, of frequency omega c plus two sinusoidal waves, these two sinusoidal waves with frequency slightly different from omega c, called as the upper sideband and the lower sidebands. So, the frequency spectrum of the amplitude modulated signal is as shown. This is the modulated wave and the frequency spectrum is shown here, where the amplitude is varied with the frequency omega. Omega c has an amplitude AC, omega c plus omega m. This is the upper side band, has the amplitude mu AC by 2, and the lower side band or lower side frequency has an amplitude of mu AC by 2. This is the frequency spectrum. As long as broadcast frequency omega c are sufficiently spaced out from USB and LSB so that the sidebands do not overlap, different stations can operate without interfering with each other. Okay.
Tips to get 98% marks in physics. Always note the video in a copy again and again till you succeed. This new video is 100% classroom teaching as in your school. All details are covered for your needs. For any more solutions to your queries, send/give comments, feedback, likes and response by subscribing. Make it better to find IT better next time. Subscribe if not subscribed till now so that you become the first one to watch the next video.
Click on the 4 connecting videos to complete the whole chapter.